Hello everyone, welcome to my channel Easy to Learn. In this video, I am going to explain about RF and microwave amplifier design. First of all, now see this diagram. This is one of the RF and microwave amplifier product. It consists of totally two ports, one input port and another one is the output port. The main purpose of this RF and microwave amplifier is what will be the input signal given to this block. It will increase the level of the signal without introducing any noticeable distortion in the signal waveform. So அந்த அளவு amplify பண்றதுக்காக இந்த component குள்ள உள்ள என்ன இருக்கும்னா active as well as passive element will be there. So earlier days like TWTE, Klystron invent பண்ண periodல the RF and microwave amplifiers are relayed in the form of tube. So after 1970s, due to semiconductor technology development, nowadays they use transistor based devices like silica BJT, silica MOSFET, GAS as RF and microwave amplifier. Okay, so உங்களோட syllabus எப்படி அப்படின்னா இந்த RF and microwave amplifier ஒரு transistor based model அப்படின்னு consider பண்ணி they're considering as a two-port network model. That will look like this. It's a two-port network model. Okay, in the S parameter காட்டிருக்க இந்த area which will describe the RF and microwave amplifier. Okay, that amplifier need one input block as well as the load side. So for that it is connected with a source voltage Vs which is series with source impedance Zs, and similarly the output from the port is connected to the load side which is represented as Zl. And இப்போ உங்களுக்கு என்ன தெரியணும் அப்படின்னா இந்த டூ போர்ட் நெட்வொர்க் மாடல் இருக்கு இல்லையா, இந்த மைக்ரோவேவ் காம்பனன்ட் டூ போர்ட் நெட்வொர்க் மாடல் which is analyzed based on the scattering matrix or S parameter. இங்கே ஏன் ஸ்கேட்டரிங் பேராமீட்டர்ஸ் யூஸ் பண்ணுறாங்க, இங்கே ஏன் இசட் பேராமீட்டரோ இல்லை ஹெச் பேராமீட்டரோ, இதுவும் ஒரு டூ போர்ட் நெட்வொர்க் தானே, இது அனலைஸ் பண்ண யூஸ் பண்ணியிருக்கலாம் இல்லைன்னா இந்த இசட் பேராமீட்டர் ஃபார் எக்ஸாம்பிள் இஃப் யூ ஆர் சூஸிங், ஓகே, பேசிக்கலி இட் இஸ் மெயின்லி யூஸ்டு ஃபார் லோ ஃப்ரீக்வன்சி அப்ளிகேஷன். ஃபர்ஸ்ட் திங். செகண்ட் திங், ஃபார் எக்ஸாம்பிள் இசட் பேராமீட்டர் எடுத்துட்டா they will utilize two condition. One is open circuit condition, another one is the short circuit condition. That two kind of condition is not applicable in the microwave frequency range. Okay, so that's why they are going for this scattering matrix parameter for analyze this two port power gain of the RF and microwave amplifier. One thing. Second thing, the scattering matrix is especially utilized for analyze the microwave components. Okay, so the microwave amplifier design is especially explained based on two port S parameter model analysis. Okay, here this V1 plus represent the value of voltage which is present in the input side of the network, that means instant voltage, and V1 minus represent the value of reflected voltage from port 1. Similarly, V2 plus represent the value of instant voltage at port 2, and V2 minus represent the value of reflected voltage from port 2, and gamma S, gamma N represent the reflection coefficient towards source side as well as input side of the network. Similarly, gamma out and gamma L represent the reflection coefficient in the output side of the network as well as towards the load side. So these are some specific content you should remember to attend the MCQ question. So based on this two-port network design, there are some formulas are there. Now see this formulas. These are the formula you should remember. So இது ஒரு amplifier இல்லையா, so கொடுக்குற power it is going to amplify the signal. Am I right or not? So based on that, here they are going to discuss about four power. One is PAVS. PAVS represent power available from the source, and PIN represent power delivered to the input side of the network. PAVN represent power available from the network, and PL represent power delivered to the load. So based on these power, there are three gain formulas are there. One is a transducer power gain which is represented as GT, and the formula is PL divided by PAVS. பேசிக்காக கெயினோட ஃபார்முலா எப்படி டெலிவர் பண்ணுவாங்க அப்படின்னா அவுட்புட் வர்சஸ் இன்புட். ஸோ இங்கே PL divided by PAVS, that means output delivered to the load divided by power available from the source. So here they are dealing with source as well as load. Therefore, transducer power gain is depend on Zs and Zl. why they are giving this dependency factor na சில நேரங்கள்ல MCQ questionல they will ask transducer power gain depends on what factor, either ZSI, ZL or ZN and ZL, like that they will ask. You have to click it out based on the condition. Okay, similarly the available power gain which is represented as GA and the formula is PAVN divided by PAVS. Okay, so PAVN represent available power from the network and PAVS represent available power from the source side. Okay, so these are the true available power in the two-port network, and this is especially related to source side. So this available power gain depends on only source impedance ZS. Similarly, the third gain is the operating power gain, which is represented as GP, and the formula is PL divided by PN. PL represent power delivered to the load and PN represent power available in the input side of the network. That means power delivered to the input side of the network. Okay, so these are relating entirely the load side. So this operating power gain depends on only load impedance ZL. So these are the some formula you should remember, as well as these two condition is very important. Okay, that is the first condition is if you want to transfer maximum power available from the source, that means maximum power from the source, that's the condition. Maximum power available from the source which is equal to the power delivered to the input side of the network when gamma in equal to gamma S conjugate. Similarly, maximum power available from the network which is equal to power delivered to the load when gamma L equal to gamma out conjugate. These are the two conditions you should remember. The main reason behind this is, இப்போ நம்ம ஒரு transmission line எடுத்துக்கலாம், சரிங்களா? ஒரு transmission line எடுத்துக்கலாம். அந்த லைக் வந்து இந்த மேக்ஸிமம் பவர் ட்ரான்ஸ்ஃபர் தியரம்னு ஒன்று படிச்சிருப்பீங்க. ஸோ அந்த மேக்ஸிமம் பவர் ட்ரான்ஸ்ஃபர் தியரமில் ஒரு கண்டிஷன் வச்சுருப்பாங்க. இஃப் யூ வாண்ட் டு ட்ரான்ஸ்ஃபர் மேக்ஸிமம் பவர் டு த லோட், the source impedance equal to complex conjugate of the load impedance. Okay, the meaning is ஒரு பக்கம் impedance வந்து அதாவது source side R plus JXL னா load side R minus JXL னு இருக்கும். ஸோ அந்த மாதிரி இருக்கும்போது the reactive element effect may be eliminated. So due to that pure resistive load, what will happen, the power factor is unity. அதாவது சிம்பிளாக சொல்ல போனால் the source amplitude is in phase with the output side. So due to that in phase nature, maximum power can be delivered to the load side. This is the condition. This is for maximum power transfer theorem. So இங்க இது வந்து microwave range frequency இல்லையா? So microwaveல they are dealing with the reflection also. Therefore, they are giving the condition as what? Gamma in equal to gamma S complex conjugate. Okay, apart from these formulas, there are some formulas there you should remember. The first one is gamma L, which is nothing but the reflection coefficient seen looking towards the load side. Gamma L equal to ZL minus Z0 divided by ZL plus Z0. அதே மாதிரி gamma S இருக்கு, reflection coefficient towards the source side. So looking towards the source side is ZS minus Z0 divided by ZS plus Z0. So MCQ will sometimes they will ask the question of gamma L, otherwise gamma S. So when you remember the formula, you can solve the small problem. Okay, then reflection coefficient towards the input side of the network, which is equal to S11 plus S12 S21 gamma L divided by 1 minus S22 gamma L. Okay, this S1 and S21 S22 are actually நம்ம இந்த microwave amplifier எப்படி கன்சிடர் பண்ணியிருக்கோம், 2-port network. So S matrix for 2-port network, ஏன்னா S matrixங்கிறது square matrix. So totally it consists of 4 parameters, S11, S12, S21 and S22. So these are the 4 parameter which will represent. இப்போ ஒரு எக்ஸாம்பிளுக்கு எடுத்துக்கிட்டா S12 எடுத்துப்போம்னு வச்சுக்கோங்க, S12. Okay, இந்த 1 represent reflected wave from port 1 and 2 represent incident wave from port 2. That's the relation, output versus input, அதாவது reflected versus incident. Okay, at port 1 or port 2, like that the notation will represent. So similarly gamma out, அதாவது reflection coefficients looking towards the output side of the port. Okay, இல்லைனா port 2. So that is equal to port 2 இல்லையா, அதனால S22 plus See this S12 S21 gamma S divided by 1 minus S11 gamma S. It's look like somewhat similar to gamma in formula. Either one you remember it, based on that second one you write it. ஏன்னா the input side of the network அப்படின்னா port 1, அதனால இங்கே S11, ஆனால் இங்கே பாருங்க output side of the network that is under port 2. So S22. Okay, so this is looking towards the input side na. இந்த பக்கம் நம்ம லோட இன்க்ளூட் பண்ணணும். இது அவுட்புட் சைட்னால இங்கே gamma S, அதாவது source side. Oppositely you have to include. And here now see this is the denominator factor. If it is the input side, the denominator factor is 22. And here now see this gamma out, it's output side. So the denominator is you have to include S11. So like that, any one of the formula you just remember it, and based on that remember the second formula. Okay, similarly the power gain, okay, the power gain formula G equal to mod of S21 the whole square into 1 minus mod of gamma L the whole square divided by 1 minus mod of gamma in the whole square into mod of 1 minus S22 gamma L the whole square. And this available power gain GA, which is equal to mod of S21 the whole square into 1 minus mod of gamma S the whole square divided by 1 minus S11 gamma S the whole square into 1 minus mod of gamma out the whole square. Okay, see this formulas இங்கே பார்த்தீங்கன்னா mod of S21 இப்படி கொடுத்துருக்காங்க இல்லையா. அது ரீசன் என்ன அப்படின்னா, இப்போ கொஷின்ஸில் S21 S11 இந்த மாதிரி வேல்யூஸ் எல்லாம் எப்படி கொடுத்துருப்பாங்கன்னா போலார் ஃபார்ம் அப்படி கொடுத்துருப்பாங்க. அதாவது 0.22 angle of minus 160 degree like that they will give. அப்போ mod of S21க்கு ஃபார் எக்ஸாம்பிள் நம்ம எடுத்துக்கிறோன்னா அந்த மேக்னிடியூட் மட்டும்தான் எடுக்கணுமே தவிர ஃபேஸை நெக்லெக்ட் பண்ணணும். தட்ஸ் த நோட்டேஷன் ஆஃப் mod of S21. ஃபார் எக்ஸாம்பிள் mod represent you have to consider only magnitude, not the phase. Okay, similarly the transducer power gain is, the formula is GT equal to mod of S21 the whole square into 1 minus mod of gamma S the whole square into 1 minus mod of gamma L the whole square divided by 1 minus gamma S gamma in the whole square into mod of 1 minus S22 gamma L the whole square. Okay, based on these formulas the MCQ questions are: question number 1, the ratio of power delivered to the load to the power available from the source is. Okay, the options are power gain, available power gain, transducer power gain, and gain of transistor. Okay, the question is the ratio of power delivered to the load to the power available from the source, that is PL divided by PAVS. So of course it's represented as, the answer is what? Transducer power gain. This formula already we discussed. Now the second question is, if the input and output are matched conjugately to the two-port device, then the gain is, okay, 0, infinite, maximum, and minimum. And I told you one formula, maximum power available from the source equal to maximum power delivered to the load when gamma L equal to gamma S complex conjugate, like that the relation will come. Okay, so due to that we will get, due to this conjugately matched nature, we will get maximum gain. So the answer is maximum. Now the third question, the source impedance is 25 ohm and load impedance is 40 ohm, Z0 equal to 50 ohm, and find the value of gamma S and gamma L. The options are minus 0.33 comma minus 0.11, and the option B minus 0.66 comma minus 0.111, and option C minus 0.111 comma minus 0.333, and option D minus 0.999 comma minus 0.666. The answer is minus 0.33 comma minus 0.11. See, I already discussed what's the formula for gamma S, which is equal to Zs minus Z0 divided by Zs plus Z0. Similarly, gamma L equal to Zl minus Z0 divided by Zl plus Z0. When you substitute the value on this formula, now I will show you the way. See this is the formula. I am substituting the value. The value is Zs equal to 25 and the characteristics impedance Z0 equal to 50. When I am substituting, I am getting gamma S equal to minus 0.333 and gamma L equal to minus 0.11. This is the answer. Now the fourth question, high gain is not achievable at microwave frequencies using BJT amplifiers because device construction, complex architecture, ports are not matched at high frequencies, none of the mentioned. Actually இந்த BJT ஆம்பிளிஃபயருங்கிறது பேசிக்காக லோ ஃப்ரீக்வன்சி ஆம்பிளிஃபயருக்கு டிசைன் பண்ணது இனிஷியல் டேஸில் பைபோலார் ஜங்ஷன் டிரான்சிஸ்டர். ஓகே, ஸோ இப்போ இது எப்படி இருக்கும் அப்படின்னா, இந்த பைஜங்ஷன் டிரான்சிஸ்டரை நம்ம 2 போர்ட் நெட்வொர்க் மாடலில் Z பேராமீட்டர் H பேராமீட்டரில் we can analyze it. ஓகே, ஸோ அப்படி பார்க்கும்போது எப்படி இருக்கும்னா, அந்த போர்ட் இருக்கு இல்லையா, இன்புட் அண்ட் அவுட்புட் போர்ட் இனிஷியலாக மேட்ச் ஆகும். பட் when the frequency start to increase, that port will be unmatched one. So due to that, we won't achieve high gain at microwave range frequencies. So the answer is ports are not matched at high frequencies. Now the fifth question, the reflection coefficient seen looking towards the load is option A Zs equal to Z0, option B Z0 minus Zs, option C ZL minus Z0 divided by ZL plus Z0, and option D Zs minus Z0 divided by Zs minus Z0. The question itself, they provided coefficient looking towards the load, that is gamma L equal to, the answer is ZL minus Z0 divided by ZL plus Z0. Now the sixth question, for a 2-port network, the voltage reflection coefficient seen looking towards the source side. Source side, already we discussed one formula. The options are plenty, 4 options are there, but you know the answer, no? Zs minus Z0 divided by Zs plus Z0. Now the transducer power gain of your 2-port network is dependent on, okay, the options are Zs and ZL, and option B Zs, option C ZL, option D independent of both the impedances. The answer is the first formula for the transducer power gain itself. I explained it's depend on Zs and ZL. Okay. Now the 8th question, gain of an amplifier is independent of operating frequency. Whether this is true or false. Okay. The answer is false. Okay. The reason, பொதுவா gain of the amplifier என்ன சொல்லுவோம், output versus input. So that is especially based on impedance values. Okay, it is independent of operating frequencies. Okay, and the formula பார்த்தீங்கன்னா frequencyங்கிற notations இருக்காது. And now the 9th question, gain of a conjugate matched FET amplifier is given by the relation option A RDS f of t the whole square divided by 4i of f of square, option B the reciprocal of option A, and option C RDS divided by RI, and option D none of the mention. Okay, the answer is option A, because the PET consists of 3 ohms gate drain source. So the gain of the amplifier always depend on output versus input, no. So output always taken from drain to source. Okay, so RDS divided by RI will be the correct relation, but here they are expressed in option C RDS divided by RI. So நமக்கு RDS divided by RI only will give the resistance value. Okay, so here it will consist of the frequency value also. Therefore the answer is RDS f of t the whole square divided by 4 RI f of square. Okay, thank you so much for watching this video. If you like my video, kindly share my channel. Thank you.